This video is to help you with the data analysis for the center of gravity and torque experiment. In part A of the analysis, please take a picture of your triangle balanced on your finger and upload it. To upload it, simply click on the box and navigate to where your files are stored. Select the file and upload. So I just uploaded a screen grab from my video. In part B of the analysis, this relates to part 11 of the experiment, where we're balancing 4 coins at 4 inches with a single coin placed at a distance that we determine in the experiment. Enter in the distance that you measured in your experiment. In my case, that was 16 inches. So putting the value in the unit into the box there. Here we're going to use that data to verify if the theory is correct. What the theory is saying is that placing a coin, if these coins, for instance, the weight of them acts downwards at a distance of 4 inches, that creates a clockwise torque about the pivot point. However, this single coin, the weight of this single coin acts at a larger distance here, and that creates an equal and opposite counterclockwise torque. Because the clockwise torque is being counteracted exactly by the counterclockwise torque, there should be no net torque on the balancing yardstick when it is balanced. And that's analyzed over here. So we can calculate the torque in units of quarter, the weight of a quarter multiplied by inches. For clockwise torque, we have 4 coins at 4 inches, and that equals 16 coin inches of torque in a clockwise sense. In my case, X was equal to 16 inches. So the counterclockwise torque was equal to 1 coin multiplied by 16 inches is equal to 16 coin inches. And we can see here that the clockwise torque is being balanced by the counterclockwise torque, which is why the yardstick remains level. So once you've done that analysis, you can comment on your results here. In part C, that relates to part 12 of the experiment. In part 12 of the experiment, we have 2 sets of coins that are creating clockwise torques. So for instance, we have 2 coins creating a clockwise torque because they're placed 4 inches from the pivot, and another 2 are placed 8 inches from the pivot. These 2 clockwise torques add up. So for instance, these 2 coins placed at 4 inches gives us 8 coin inches of clockwise torque. These 2 coins at 8 inches creates 2 times 8, which is equal to 16 units of torque in coin inches. The total clockwise torque is then equal to 8 plus 16, which is 24. Now let's compare that with the counterclockwise torque, which is created by the 4 coins. So we have 4 coins here that are placed X inches from the pivot. X is determined by experiment. In my case, X was equal to 6, and we can enter that value over here. You can type that in, or in my case, I'm using my pen tablet to fill in the form. So, having determined that the clockwise torque is 24 coin inches, the counterclockwise torque in my case is equal to 4 coins times 6 inches, which is 24 coin inches. We can see that the clockwise torque is being balanced by the counterclockwise torque in my case. So with with my measurements, there seems to be quite good agreement between theory and experiment. For your own data, please provide analysis as to how closely your results are aligned to the theoretical predictions. In Part D, use the same approach that we did in Part A to upload a picture of a yardstick showing Part 12, showing the stick in a balanced condition. And that's the analysis. Thank you.